Recall that sine theta over cos theta is the same as tan theta. Also, sine squared theta plus cos squared theta equals 1 from the unit circle and using Pythagoras. Now we're going to look at some reciprocal functions. And the reciprocal functions are sec theta, which is 1 over cos theta, cosec theta, which is 1 over sine theta, and cot theta, which is 1 over tan theta. Now you'll notice here that cot theta is written as cos over sine, which of course is 1 over tan theta. Alright, we're going to have a look now at some questions where we need to use our exact values. I'm going to do sec of 2 pi on 3. First we'll express that as 1 over cos of 2 pi on 3, and remembering that that's the same as cos of pi minus pi on 3. So we're in the second quadrant. This will have the same absolute value as cos of pi on 3, but it needs to be negative because we are in the second quadrant. Cos of pi on 3 from your exact values table, remember, is a half. So we have 1 on negative a half, which gives us negative 2. Now cot of 5 pi on 4. Remember, cot is 1 over tan, so we have 1 over tan 5 pi on 4, and we re-express that as tan of pi plus pi on 4. Okay, now that's going to have the same value as 1 over tan of pi on 4, and remember that we are in the third quadrant, which is the tan quadrant, so it will be positive. So we have 1 over 1, which of course is just 1. Looking at cosec of 7 pi on 4, remember cosec is the reciprocal of sine, so it's 1 over sine of 7 pi on 4. We'll re-express that as sine of 2 pi minus pi on 4. From symmetry, that's the same as sine of pi on 4, but it's going to be negative because we are in the fourth quadrant. So that's the cos quadrant, sine will be negative. That gives us 1 over negative root 2 on 2. So the reciprocal of that is negative 2 on root 2, and we can rationalise that denominator and do some cancelling just to end up with negative root 2. Let's now solve some equations for x. We've got sec x equals negative 2, and we want solutions between 0 and 2 pi. So sec x will be the reciprocal of cos x, and so cos x will be negative a half. Now from the unit circle, we know that cos is negative in the second and third quadrants. The base angle for inverse cos of a half is pi on 3. So we have x will be pi minus pi on 3 and pi plus pi on 3. So we'll get x is 2 pi on 3 and 4 pi on 3 as our solutions. The next example is cot x equals negative 1. Remember, cot is the reciprocal of tan, so if 1 on tan is negative 1, tan itself will be negative 1. Now tan's going to be negative in the second and fourth quadrants, so we want pi minus and 2 pi minus the base angle. Our base angle will be inverse tan of 1, which is pi on 4. So we require pi minus pi on 4 and 2 pi minus pi on 4. Let's simplify that. We get 3 pi on 4 and 7 pi on 4. Now we're going to look at some Pythagorean identities. In particular, we had sine squared plus cos squared equals 1. If we divide every term in that expression by cos squared theta, we notice that we'll get 1 plus tan squared theta equals sec squared theta, and that's going to come in useful when we start looking at proofs. Likewise, if we decide to divide that original expression there, this time by sine squared theta, we'll notice that we'll get cot squared theta plus 1 equals cosec squared theta. So we need to keep that one in mind as well and perhaps memorise it. Let's look at some examples. If we've got cosec x equals 7 over 4, find cos x. Now remember, cosec is the reciprocal of sine, so sine x will be 4/7. And we can use the identity sine squared x plus cos squared x equals 1. So when we square sine x, we get 16 over 49 plus cos squared x equals 49 over 49, which of course is the same as 1. That gives us cos squared x is 33 over 49, and cos x is root 33 on 7 therefore, or negative root 33 on 7. Now the original question had cosec x as positive, so sine x was positive, so we could be in the first or the second quadrant, so that's why I've taken both the positive and negative values for cos. The next one, we have sec x is negative 3 on 2, and this time we are in the second quadrant. We want to find sine x. So sec x is the reciprocal of cos, so cos x is going to be negative 2 over 3. Now, that identity we used before, sine squared plus cos squared equals 1, it's often useful just to remember that sine x is the square root of 1 minus cos squared x, and it's also true that cos x is the square root of 1 minus sine squared x. So I'm going to use that there on the left now. So sine x is 1 minus the square root of 1 minus cos x squared. So I get 1 minus negative 2/3 squared, 1 minus 4/9. So I'm after the square root of 5/9, so I get root 5 on 3. Now I'm taking the positive answer because I know I'm in the second quadrant, which is the sine quadrant. The next one, we have sine theta equals 3/5. Oh, and by the way, with that, I've just written there positive since we're in the second quadrant. Okay, let's go ahead. So now we've got sine theta equals 3/5, and we are between pi on 2 and pi, so again we're in the second quadrant. So cos theta is the square root of 1 minus sine squared theta. I'm going to get cos theta is negative 4/5. Now I'm choosing the negative answer because I know cos will be negative in the second quadrant. Also to find tan theta, we'll just say sine theta over cos theta. So we get 3/5 on negative 4/5, and we can cancel there to get negative 3/4. Now we're going to look at some identities. Now we're going to prove the identity that 1 on 1 minus cos theta plus 1 on 1 plus cos theta equals 2 cosec squared theta. Now the normal way to approach this is to start with one of the two, left or right hand side, usually the left side, and see if we can work our way towards the right hand side. Okay, so on the left hand side we note we've got two fractions there, so we're going to combine those to get using a common denominator. So I'm going to do 1 times 1 plus cos theta plus 1 times 1 minus cos theta over 1 minus cos theta times 1 plus cos theta. Now that top line simplifies to 2, and the bottom line is the difference of two squares. So we get 1 minus cos squared theta, which of course is sine squared theta, and 2 over sine squared theta. Well, when sine squared theta there is on the bottom, we'll bring it up the top because we know its reciprocal is cosec squared theta. And then we normally finish off by saying this equals the right hand side, so therefore we've proved. What we set out to.